Hello and welcome to the course of Advanced Strength of Material. In this course, so far we have studied about bending stress and shear stress that is happen to subject in the beam. That another type of stress in this lecture. This will be new chapter, and this is your 9th lecture. In this chapter, we will be talking about your combination of the bending moment and so we will be talking about combination of bending moment and bending stress and direct stress. Okay, so here combination of bending stress and direct stress, that we will be talking. So first let's start our lecture with our lecture objective. So our lecture objective for this lecture is to know about direct stress and bending stress. So first we will know about what is direct stress and what is our bending stress. Then we will know about eccentricity. So this is a new term, eccentricity. So this new term we will discuss in a broader manner. So what is eccentricity, what is the importance of this eccentricity. Next we will introspect about the effect of the combination of direct and bending stress. So what will be the effect of the direct and bending stress, and the combination of these two stresses, that we will see. So first, direct and bending stresses. So what is direct stress, what is bending stress? So just imagine in the last lecture, or from the beginning of this course, beginning of this advanced strength of material, or in the strength of material, what we are talking about, we are talking about stress, and though that stress is generated from the external load. So how the stress is generated? Whenever any external load is applied to a body, at that time what happens? Body tends to deform. That force reaction, the action of that force is to deform the body. So always what happen, always force tries to deform the body, and body by its property, by its own property of the material that by which that body is made, by that property of that material, body, what does body do? Body opposes that force, and this that means body gives a reaction force, and that reaction force is equal and opposite from Newton's law, that we know. And this reaction force, when we see this reaction force per unit area, at that time what happened? Due to this reaction force, stress is generated inside the body. So how the stress is generated, that we have already know, and we have discussed it in the last semester also, and in all the previous lectures we are discussing about this stress only. Now in this lecture, what is special about direct and bending stress, that we will be considering real life situation. That means in here, like you will see in the next slide, that we were considering a column that is completely practical situation. Okay, you have seen that C clamp, you have seen in case of bench vise, you have seen in case of drill punch. So in all of these cases, these are the practical applications. So in all of these cases, what we can see that force is acting, and due to that force, what is happening? Stress is generating. And what is that stress? What are the nature of that stress? How that stress is generated, distributed over the whole length of the body? This will be our area of interest in this chapter, that is combination of bending and direct stresses. So now let us define that what is direct stress, and why the direct stress is generated, and what is bending stress, that we will define in this lecture. So First, see direct stress. When the direct stresses alone produced in a body when it is subjected to axial, tensile or compressive load. So that means axial, tensile and compressive load. That means if the body is symmetrical or not, the each and every body has an axis. That axis is nothing but plane passing through its center of gravity. So in any body there is two axes in a 2D plane. If we can see that there is two axes, that two axes can pass through the center of gravity. That means whenever these axes are nothing but the planes which passes through the center of gravity. Now in this plane whenever any tensile, that means tensile force, that means the force direction will be outside, or compressive force. So whenever any axial, tensile or compressive force acts on the body, axial means on the axis. On which axis? On the axis which is passing through the centroid of the body or through the center of gravity of the body. So that is it. So see here, the knowledge of strength of material, that means this knowledge of center of gravity, knowledge of general stress, these knowledge are very important to understand the next topics of this advanced strength of material. So I will request to go through the center of gravity chapter, or just remember that center of gravities, and remember the principal and simple and principal stresses. These things you should know, and these things have been well taught in the last semester. Okay, so now we are moving on. So what is direct stress? So whenever the force acting is in the axial position, that means whenever the body is subjected to axial, what type of force are acting? Tensile and compressive load. So whenever axial, tensile and compressive load are acting on the body, at that time what happen? At that time body is subjected to direct stress only. There is nothing else. There is only that tensile and or compressive force. That means this condition is known as direct stress. And for this direct stress we have calculated the value of the stress and value of the deformation due to this direct stress. So far we have only discussed about this direct stress only in the last module. We have introduced one new thing, that is theory of bending. And in the theory of bending, what we can see, due to bending there is another type of stress that can be generated or that can be induced in the body or in the workpiece. So that stress is known as bending stress. So that bending stress is produced in the body. When the bending stress is produced, from the last chapter we know that bending stress will only be produced when the body will be subjected to bending moment. So for bending stress, the most important topic is bending moment, because we know that bending stress equation, from the bending stress equation we know that sigma b is equal to nothing but m by I into y. That's what we have found in the last module, right? So we know that value of the bending stress is m by I into y, where y, I, these are the constant, because for a body which is not changing its shape, the moment of inertia and the distance from the neutral axis to the topmost fiber is your y. These two are not changing, but bending moment, the value of bending moment is very important. So for generating or for producing the the bending stress, what is important? The bending moment should be there. So from here we can conclude two things. First, direct stress. When the direct stress will be produced? Direct stress will be produced whenever there is axial, tensile or compressive forces acting on the body, and bending stress is produced whenever there is bending moment. Okay, so we for now we have understood, I think we have understood one thing, that is, for direct stress we have to know about the axial stress, the value of the axial force, or whenever any axial, compressive or tensile force acting on the body, at that time what happens? Direct stress produced. And similarly, whenever a bending moment is acting on a body, at that time what is happening? At that time your bending stress will be generated. So if in any condition, if we can imagine a condition where this axial load and the bending moment both are acting at the same time, then what will be there? Then the stresses, both the stresses, bending stress and the direct stress, both the stresses will be produced at the same time. Now from the previous knowledge, we can say that the direction of the bending moment, what will be the direction of the bending stress? The bending stress direction will be nothing but it's normal to the your cross section. So bending stress acts normal to the cross section. Similarly, what will be the direction of the direct stress? That we also know from our previous knowledge, that direct stress that also acts normal to the cross section. So if both the direct stress and bending stress has same line of action or same direction, then what we can do? Then we can add them algebraically to get the resultant from them. So overall, if we can have the idea, what will be the idea, or what will be the conclusion of this concept of direct stress and bending stress? That is, due to whenever there is direct stress, or whenever there is axial force and bending moment acting together in a body, which is more often to be the case in the practical condition. In the practical condition, we can see that axial force and the bending moment will act together. At that time, what we can say? We can say that bending stress and direct stress, both type of the stress will be generated in the body, and these two stress have same direction. So we can add them algebraically so that we can get the resultant stress from these two. So this whole concept is the combination of bending stress and direct stress. I guess I am clear now. Moving to the second topic of here, so let us see an example of the direct stress and the bending stress. So see here, in the real life condition, if we have a column, what is column? Column is nothing but column is a member which can take only vertical loading. So understand two things. There is in the you have already said these terms. Okay, now you have to know the difference between these things. So we have always known about three things we know. First one is bar. Second one is, first one we know about is bar. Second one is beam. And the third one is column. So these three things we have always said about these three things. But what is the difference between these three things? If all those three are same, then why the name is not the same? Because they are not same. Because see here, from the strength of material or from the mechanics of the material view, we can say that bar is a member of a structure, bar is a member of a structure which can take only the horizontal load, or only this type of the horizontal load, or only this axial load can be given to the bar. This is the bar. And beam, what is beam? Beam is nothing but, beam is similar to bar, but bar does not deflect. That means in the beam there is load, that is vertical loading can be possible, vertical loading, bending moment, this type of the things can be possible in case of beam. So beam is a member which can take up the vertical loading along with the horizontal loading. That means in case of beam, beam can take up both the load, vertical and horizontal. And column can only take the vertical load. So whenever we use the term column, that column is meant to take the vertical load only. If we load a column axially, that column will fail eventually. Okay, so the thing is that you have to know the difference. So these are the difference. The bar can take only the horizontal load, beam can take horizontal as well as vertical load, and your column can take only the vertical loading. Okay, so here we are considering a column. So in column, the combination of the bending and the direct stress will be seen very clearly. So for example, we are taking only, means we will discuss only about this column. So consider the case of a column which is subjected to a compressive load P acting along the axis of the column as shown. So what is axis again? What is axis? Axis is nothing but a line which passes through its center of gravity. So this is axis. Whenever the load is applied along the axis of the column as shown in the figure, what will be the case? So at this time the load will cause direct compressive stress, that would be direct compressive stress that would generated inside the body or induced inside the body, and the load and the stress, intensity of the stress will be uniform throughout the cross section of the column. So that is our direct stress. So whenever this compressive load P is acting along its axis, at that time a compressive stress will be generated inside the body, and which is uniform throughout the cross section of the column. Now if we assume that sigma 0 is the intensity of the stress, and A is our area of the cross section, P is our load which is acting in the column, then stresses can be calculated by nothing but stresses is force per unit area. So this is simple stress or direct stress. This sigma 0 is simple stress or your direct stress. Now we will see about the special term, that is eccentricity or E. So if we consider a similar column, but the force is not acting along its axis, but it is acting some distance apart from that, some distance apart from the axis. This distance is known as some distance E apart from the axis. Okay, now this distance E is known as eccentricity of the load. This is the eccentricity of the load, and this eccentric load and this type of loading is called eccentric loading. So this eccentric loading will cause direct stress and bending stress. So due to this eccentric loading, direct stress and bending stress will be generated or will be induced in the column. So see the difference. here in this case, when the load is acting along the axis, what is happening? There is only the direct stress, that is our sigma 0 is P by A. It's so simple. Now in the real life condition, most of the cases the load is eccentric. That means load is not acting on the axis of the body, but it is acting apart, some distance apart from the axis. Those distance which that distance is known as our eccentricity. Now whenever there is eccentricity to the load, at that time this type of the loading condition is known as eccentric loading. So now this statement that in case of eccentric loading, the eccentric loading causes direct and bending stress, or combined effect of direct and bending stress. This can be proved by using this can be proved in the next slide, that is here. See, in the case of combined or direct bending, see, this is the condition of the eccentric bending. Now if we imagine that here in the through the axis there is a P, that is that P compressive force is acting, and to resist it a similar force P will be acting in opposite direction. Now at this point there is no force, that means this P cancel out, but we can imagine this, and by imagining this we can see in case of eccentric loading there is a set of three forces that is acting on the body, and the first type of the forces is this. This will cause that compressive force acting, this compressive force acting on the axis, and this will cause direct stress and a couple. What is the definition of the couple? Couple is nothing but when the two equal and opposite force act at a distance. At that time this condition in the terms of mechanics is called couple, and the moment of this couple, if the distance between these two is r, then the moment of this couple will be the magnitude of these two equal and opposite force, that is P minus your P into R. So here in this case, so this is will generate our direct stress. That means due to this direct compressive force, the direct stress will be generated, and another two set of force, that is this P and this equal, and these two forces are equal and opposite in direction, and it has a distance of E. So that means that would give us the here a couple will be generated due to these two force. The couple due to this, what is happening, due to this our moment of this couple will be P into E. Now this couple, so due to this bending moment that is formed by the couple, the bending stress will be formed in this body. So we can see that due to this eccentric loading, both direct stress and bending stress is generated in the body. So that is it. So hence due to eccentric loading we can create direct stress as well as bending stress, and both the direction of the direct stress and bending stress will be similar, and it will be in the same direction. So algebraic addition to these two stresses, that is direct stress and our bending stress, can give us a single resultant stress that can be produced. and this value of the stress has two value, maximum and minimum value of the resultant stress. This we will be determine in the next class, and the stress distribution diagram also we will draw in the next class, and this resultant can be determined for different cases. What are those different cases? When the load is subjected, first when the load is subjected to symmetrical section such as rectangle at an eccentricity with one principal axis. That means that see, I have said earlier that in 2D case we can have two axes, that is in x and y direction. So in the x direction, whatever moves through the axis moves through the through your center of gravity is an axis, and in the y direction also. So we have now we have two axes. So in first case, the load, when the load is eccentric to only one axis, that we will consider, or that we will describe for a symmetrical section. Next, when the load is subjected to symmetrical section but the eccentricity will be with two principal axes, means when the load is applied here, somewhere here, so that means this is some at some eccentricity from this axis also, and at some eccentricity from this axis also. So this type of, when the load is applied here, this is called eccentricity with the two axes. This is a method. And another case can be happen, that is the load is subjected to unsymmetrical section. Unsymmetrical section means T section, your this type of the section, any section, that is tapered section with a hole inside. So this type of the case, in this type of the case, there is in this type of the case, when they are applied or they are loaded with the eccentric loading, that time also resultant stress can be determined. But in our syllabus, the one case is there, that is the first case, that is when the load is subjected to symmetrical section such as rectangle at an eccentricity with one principal axis. So that due to one principal axis, the eccentricity, due to this eccentricity, we will determine the expression for maximum and minimum stress, and we will see the value of direct stress and value of the bending stress in this case, in the first case only, in the next lecture. So thank you for being here. Hope you enjoy this lecture, and if you have any difficulty, you may ask me in the live class. So thank you.